Proteus Motion is a training tool built to perform for professional athletes. This handle is how the athlete connects to the machine, and ensuring the athlete's safety while using the Proteus Motion is extremely important. The handle needs to be both strong enough to endure the forces of a Major League Baseball swing and lightweight enough to simulate the feel of the bat in the hitter's hand. It's a highly designed assembly which will need to be virtually tested to meet all of these design criteria. Let's take a look at how we can use some of the new features in SOLIDWORKS 2025 to speed up the analysis of this handle and also increase the accuracy of the results. Firstly, there are several components that are required for the handle to function properly, yet many aren't integral to the handle's structure. New in 2025, we can now select the structural components we want to keep in the analysis and then exclude all of the others. This is a huge time saver when working with large assemblies. These moving parts are all connected with pins. Virtual hardware is a great way to reduce the overall scope of the analysis without sacrificing accuracy. Now, virtual pins can be defined using distributed coupling technology, which allows accurate transfer loads from the surfaces where the pins are located, increasing the overall accuracy of the analysis. This handle is connected to the rest of the Proteus Motion machine, but adding a rigid boundary condition would over-constrain the model. In reality, there would be some compliance to the rest of the machine, which would act as a stiff orthotropic spring. New in Simulation 2025, a new orthotropic spring type can be defined with unique stiffness properties in all orthogonal directions, plus torsional and bending stiffnesses as well. Before we run the study, we need to mesh the model. In SOLIDWORKS 2025, assemblies that contain identical parts will be meshed 15% faster while using the blended curvature-based mesher. Plastics 2025 can help in designing the perfect part right from the get-go. The new results break down overall warpage displacement into unbalanced cooling, orientation, and non-uniform shrinkage, give a much better insight into the deformity characteristics of the model. This ensures that the virtual prototype more closely matches the physical one.